In this video, we're going to finish off our work on Pythagoras' theorem by looking at some problems in a context, some worded questions based around this topic. These are notoriously difficult, so you need to draw a picture so you can visualize the problem. So let's start with this one. As you can see, we've got a ladder that's 5 meters long, and the bottom of the ladder is 2 meters from the foot of a wall, and it's leaning against that wall. How high is the top of the ladder above the ground? So what we need to do is we need to draw a picture of exactly what this looks like. So as you can see, there's the wall, there's the ground, and we've got this ladder there like that, and this has formed a right angle triangle. So let's try to put some numbers in there. We know the ladder is 5 meters long, so that is 5 there. We know that the ladder is 2 meters from the foot of the wall, so we've got 2 meters there, and this is enough information to find out how high the top of the ladder is from the ground. We can use Pythagoras' theorem again. We've got the hypotenuse, so this is a subtraction. If we call the value we're trying to find x, we can say that x is going to be 5 squared, take away 2 squared, square rooted. So that's how we're going to find this one out. You should know that already by this stage. And of course, the answer is going to be 4.58. So I suppose we should round to 1 decimal place. The answer is 4.6 meters. Okay, let's do another one. So a ship sails 300 kilometers due west, then 100 kilometers due south. At the end of this journey, how far is the ship from its starting position? So let's imagine we're looking down on this. First of all, we're going to go 300 kilometers due west. So west perhaps is in that direction, 300 kilometers. And after that, we're going to go 100 straight down, south. How far are we away from our starting point? Well, what that means is we need to work out this distance I've just drawn there, the hypotenuse, in fact, of this right angle triangle. So, easy enough to do. We're trying to find the hypotenuse, so we're going to add. So let's call that x again. X is going to be 300 squared plus 100 squared, square rooted. That's following Pythagoras' theorem. If we do that, we end up with 316.2 kilometers. Next example, this time we have to find the area of a triangle. Now, to find the area of a triangle, there's a formula that you should all know anyway, and that is we need to do the base multiplied by the height, and then get that answer and divide it by 2. So that's how we find the area of a triangle, but of course we don't have the height of this triangle, so we're going to need to work it out before we can do that formula. So we're going to look at finding that height, and it is of course not the hypotenuse, it is one of the sides A or B, one of the perpendicular sides, so therefore we're going to do a subtraction with our Pythagoras. We need to say, if we call that height, let's call it h for height, that h is going to be 10 squared, take away 6 squared, square rooted. And if we work out what that is, we get 8 centimeters. Now we've got to put that into our formula. So the base times the height divided by 2 is 6 for the base times 8 for the height divided by 2, and our answer is 24, and we're working out an area here, so it is in centimeters squared. Now this last example is quite challenging. It involves some coordinates. Now we're going to find the length of some of these lines on this coordinate grid, so let's get started. The first one is AB, so from A to B. Now if you find those 2 points, let's draw a little line there between the two. What we're trying to do is we're trying to find the length of that line. Now, if you think about it in terms of a right angle triangle, well, we could work out the bottom of that triangle there. If we count the squares, it's a difference of 1. And we could use the coordinate points to work out the height of that triangle as well. So what we can actually do is form a triangle where we can use Pythagoras' theorem to work out the answer. So we've got 1 across and we've got 5 up. So the line AB is going to be the square root of 1 squared plus 5 squared, which will give us 5.1. We don't need units because the original question doesn't have any units. It's just 5.1. D to E, well, if we look at D to E, you can see there's the line and we're trying to find that length. And if we go down and across, we can see this one is a right angle triangle as well. So we're going across 3, and if you count the squares or you look at the coordinate points, you can see we're going up by 7. So the length of that line, DE, is going to be 3 squared plus 7 squared square rooted. And if we work that out, it is 7.6. And that's how you can work out the distance between 2 coordinate points. Now, very quickly, the last one is C through to E. Now, if we draw that, it's just a straight line. And if we count those squares, it is just 5 of our units. So C to E is 5. No need to involve Pythagoras' theorem in that question. That's all we have for this topic. That should be enough to get on with the exercise. Good luck.